Welcome and thank you for joining us today for this SPE Tech Talk with Halliburton. I'm your host for this broadcast, Joe Sinnott. And one of the biggest challenges in well construction is getting the primary cementing job right the first time. Costs to remediate a poor primary cementing job can be extremely impactful to the economics of a well. Cement and drilling engineers have long discussed what best practices should be used in the primary cementing process. However, challenges arise when there is a lack of understanding about the impact those practices are likely to have on the outcome of a specific job. We're joined today by Halliburton to hear about the machine learning barrier advisor model, which employs historical data to determine which practices are most impactful to a given cement job. These results from that model can in turn improve the probability of operational success. And if you want to improve the probability of this episode being engaging and valuable and successful to you, the audience, then take advantage of that comment box today to share your questions, your feedback, your skepticism, your opinions about today's topic. Because even though we'll be talking about ways to enhance barriers downhole, here on this live SPE Tech Talk broadcast, we don't want any barrier between you and our expert, who will address as many of your questions and comments as possible later on in the show. And if you're not ready just yet with any questions or comments for our expert, that's okay. One good way to interact for now is to let us know where you're watching from, or to go ahead and give some thought to today's audience poll question. And today's poll question is, would it be valuable in your operation to understand cementing operational risks and to know what can be done to mitigate those risks prior to job execution? Go ahead and answer A, yes, or B, no in the comment box, and feel free, of course, to add some additional color around your answer that, again, we'll address with our expert later on in the show. And speaking of our expert, let's go ahead and introduce today's guest, Walmy Jimenez, product champion of cementing software with Halliburton. Walmy's experience spans the last 12 years in various roles, including digital solutions, operational engineering, and research and development. He has authored over 20 technical papers and filed over 15 patents. And Walmy holds a degree in mechanical engineering from the Industrial University of Santander in Colombia and a master's degree also in mechanical engineering from the University of Oklahoma. Hello, Walmy, and welcome to SPE Tech Talk.
Thank you, Joe. Looking forward to our discussion.
All right. Well, I am looking forward to it as well. And to kick off the discussion today, Walmy, we know that the cementing process is critical to achieving zonal isolation and wellbore integrity. So if you would, to start things off, let us know what are the main challenges with creating and delivering a successful cement job and resulting barrier to achieve that zonal isolation that is so critical to success.
Thanks for the question. But prior to diving into those challenges, allow me to describe what are the three focus areas that are critical to achieving operational success. Number one area, Joe, is people. The people that are responsible for working on tailoring that design and that process in order to achieve operational success. They're responsible for understanding what are the best practices and lessons learned that they need to implement in order to achieve or to execute that cement job and achieve success. Number two is the process that we have in place in order to deliver that barrier, in order to deliver that cement job. The process that we at Halliburton have in place consists of 4 control points. Control point number one, where we call design review, is basically where we build the plan. We build that design of services. There is an internal peer review process that basically aligns whether that process is approved internally, and then we move that process or send that design of services to our client, to our operator, where they also approve. Once that design of services is approved, when that plan is approved, then we move to control point number 2, which is our loadout confirmation. Are we sending what equipment, what personnel, what people, what materials do we need to send to location, to the platform in order to execute that job? Then control point number 3 is our job site quality assurance. Once on location, do we have the right personnel? Do we have the right equipment? Do we have the right materials and the right quantities in order to be able to successfully execute that job? Which takes us to our control point number 4 and the last one, reconciliation. Is there any deviation between execution and the design? And if there's any, what are the lessons learned? Which best practices did we implement? And in regards to lessons learned, we capture those lessons learned whether the job is successful or not. That takes us to our third critical focus area, which are the practices. What practices are we implemented in order to execute that job? These are things such as space or contact time. Do you have the right amount of spacer to execute that job to displace that map? Do we have density hierarchy? Do you have logical hierarchy? Are we centralizing the casing sufficiently enough to be able to optimize the amount of cement that surrounds that casing and isolate the different formations? Are we rotating the pipe? Are we moving the pipe in general? Are we reciprocating? Among other factors. So those are the three critical focus areas that we focus on. So I wanted to give you that color before we go into the main challenges. Naturally, all the challenges are going to fall within: do we have the right people in place to execute the right job? Do we follow our control process, and are we implementing the right practices to be able to execute the job? So naturally, there are challenges around following our process. And in addition to that, something to note that is very important is this process is very locally focused, meaning we focus on practices and lessons learned at the local level, and what we're meaning or missing is that global connection. So are we at the local level when we execute the jobs? How are we connecting to our global databases, and how are we leveraging that information, which is another challenge, another limitation.
Great. So thanks for setting the stage there again. So people, processes, and ultimately the practices.
Correct.
But you just alluded to, I mean, you just rattled off a whole bunch of different practices, right? You know, all of the different things that you can be doing, all of the different variables that you can control. So with that being said, I think a logical follow-up is, you know, how do you do that? How has Halliburton, historically at least, been, you know, addressing the challenge of managing all of those variables, all of those potential practices to achieve a successful cement job?
Great question, Joe. So as an industry, we have used scorecards historically. That's what's an industry what we have implemented. Just to give you an example, API P65 is a scorecard system. A scorecard focuses on identifying which practices result in a successful cement job execution. At Halliburton, we have followed the same process. Basically, we have localized databases that identify which are the best practices, which are the lessons learned at a local level that are critical into achieving a successful job locally. We also have technical professionals on the specific location of specific basins where we operate that have access to a digital twin models. These digital twin models are nothing but a simulator or a software that allows us to simulate the actual job. All the parameters, the geometries, the practices that we implement, it simulates all the specific conditions of the job, but again, it's very job specific. It's focused on the specific job that you're designing for. And it does not allow, this digital twin model does not necessarily allow for assessing the operational risk in relation to the specific job and in relation to how the risk for that job correlates to our global jobs or the jobs that we execute at a global level. So it's very job specific.
Okay, so what does that look like? We've just described all of that. Again, you talk about sort of that local level, the data coming in for that specific job. Just paint a picture for us, or if you have anything to throw up here on the screen here, even what does that actually look like for somebody that might not be as intimate with the cementing process as you are, and as others that might be watching today are?
Great point, question. So great point, Joe. So in regards to the question is, the next point is, so I already described what are the challenges. What are we doing up to this point, right? So the next point is, how do we leverage the information that we do have? And the short answer for that is, we have enabled a global database. So right now, the challenge is we have these localized databases. So by enabling a global database, we can link all these localized databases to enable our engineers, or inform our engineers as to which best practices matter. What are the practices that matter? And we can also score the different jobs, right? In order to be able to reduce risk and maximize the probability of achieving success. But before I go deeper into how to leverage that information, we need to understand also what is our journey, what has been our journey historically. Initially, our journey started with scorecards, which I already described, we already discussed those. But from the digital standpoint, we started by implementing or delivering an initial tool that we call MyCem, which is our ecosystem where our control point process lives, where our control point process is stored. So it's important for me to take a step back and also remind you what that control point process are, which we already described. Control point number one, design of services. Get that design review and approve. Control point number two, are you sending the right people, the right equipment, the right materials to location? Control point number three, job site quality assurance. Once on location, do I have the right equipment? Do I have the right people? Do I have the right materials? the right quantities to execute that job successfully. And then finally, reconciliation, which is a post-job evaluation. Did I execute as well as I planned? Is there any deviations thereof? And then 5 years ago, we introduced VIDA, which stands for Verified Integrated Design Application, which is really our digital ecosystem. In VIDA, every data, every set of information that is in relation to any job we execute globally is in VIDA, lives in that digital ecosystem. In addition to that, information in regards to how do we design, how do we tailor, how we execute, and how do we validate any cement job we execute globally is also within that digital ecosystem. In addition to that, information such as what is the objective of every job we execute, what is the type of cement, what is the zonal isolation if that's the objective that the customer wants to meet, do you need a competent shoe or a combination thereof, right? Or any other objective that the customer may have. So what in addition to that, there's information in regards to what is the job type. Is it a surface casing? Is it a production casing? Is it a production liner, etc.? All that information is within VIDA. What is the geometry? Is it vertical? Is it horizontal? What is the measure depth? What are the placement conditions? Are we temperature? Which pressure do I need to execute the job? What are the properties of the fluids, right? What are the density of those fluids? Among other different factors that or attributes that go within our digital ecosystem. But also importantly is what are the best practices that we implement? All of that information in regards to which best practices each job implements go into VIDA.
Great. So a couple things you just said there, Walmy. One, obviously Halliburton trying to leverage all of the data that's out there and bring it into one spot. I want to use this as a good time to remind our audience to leverage the opportunity to ask your questions today of our expert. Go ahead in that comment box. Throw your questions in there. Throw your comments. Throw your opinions for a chance that, again, Walmy will be able to address them later on in the show. Take advantage of it. That's why we're here. That's why we enjoy doing these live broadcasts. Back to some of the other things you said, Walmy. So can you have all of this data that's out there? It's accessible, although, again, maybe historically a focus on that specific localized cement job. Let's talk about how to take advantage of all the data from a macro standpoint. So machine learning, obviously some of the fancier data science tools that are out there. How is machine learning now being coupled with what Halliburton's already been doing from a data standpoint to transform some of the decision-making processes that go into a specific cement job?
Thank you for the question. That brings us to the core of our discussion. What are we doing with our global database? Once we have access to all of this information, the main challenge is how do we couple that into a global database, which brings us to Better Advisor, which is the core of our discussion today. Better Advisor is a machine-based learning or a machine-based model that allows us to leverage that global database and score each cement job that we execute historically and each cement job that we're planning to execute in the future. How does it do that? It accounts for which best practices each job is going to implement. And based on those best practices, it determines what is the potential score. What does the score mean? The score basically assesses what is the risk level that job is going to be exposed to and what is the probability of achieving operational success. See, historically, we have people trained. We have a strong process in our control point process. What we never had is our ability to advise our engineers, our users, our clients as to which practices matter, which practices to implement in order to reduce risk and maximize operational success. Now, talking about the scoring, for a specific job, let me elaborate on the scoring process. Each job that we execute has a set of best practices that we are going to implement, right? Those set of best practices are evaluated within our digital twin model, right? Each practice we evaluate has a weight, and by computing the weight and the practices that we implement, we can calculate the score. Just to give you an example, a standoff or centralization, that's a best practices. Whether we achieve a specific standard requirement, let's say 70% or not, that defines whether that best practice is met or not. Let's assume a weight of 10% for that best practices. If I achieve it, the model will assume, okay, if it's achieved, then you have 10% weight, and so on, for every best practices that we implement. And that results in the score. Naturally, whether a practice is implemented or not has an impact on the ultimate score. Now, let's talk about what additional value Better Advisor has and implementing machine learning models in our cementing process has to us and to our clients, right? Better Advisor, in addition to scoring the job that I'm planning to define, it identifies what are the similar jobs. from our global database, bringing the global data back into perspective, right? From our global database, I'm trying to define for a specific job. It looks at the global database and it assesses or determines what are the nearest neighbors. In machine learning, nearest neighbors are jobs with similar attributes. It assesses based on a clustering approach which ones are those nearest neighbors. In addition to that, what are the attributes that it uses in order to select those nearest neighbors? Geometry. Is it vertical? Is it horizontal? What is the measure depth? What is the TBD? Placement conditions. What is the temperature at which you're placing the job? Fluid properties. What are the densities of the fluids that you're designing for? Job type. Is it surface casing or is it production casing or liner? And also, what is the objective? What is the objective that the operator, that the client wants to achieve? Based on these attributes, it detects those attributes from the job that I'm designing for, goes to the global database, and assesses which are the closest jobs with the same attributes, which are the similar jobs. Then the model displays a histogram with the scores of each of those nearest neighbors. Keep in mind, those nearest neighbors are successful jobs with similar attributes than the one I'm designing for. And it displays a histogram with the score of all of those nearest neighbors. That could be at least 50 of those nearest neighbors. And it also displays the score of the job that I'm designing for. So it tells me, are you in the low tier of those operational success score, or are you in the high tier? If you're in the low tier, that means that you have to improve the plan. You have to improve the job. How do you do that? The model also tells me which practices to improve. Not only that, it also tells me which practices, what is the impact of each practices. So for instance, if my score is 30% and I want to move to 70%, the model will tell me which practices to improve, whether I need to centralize, whether I need to achieve logical hierarchy, and what is the impact of each one of those. So it guides me as to what to do in order to improve operational success and reduce risk. But there's more.
So again, it's painting a clear picture. It's giving you some odds, if you will. It's showing you which variables might have an impact, which I think, honestly, everything you just described is maybe provides a great time to revisit our poll question from earlier. So we asked the audience at the outset today, would it be valuable in your operation to understand cementing operational risks and to know what can be done to mitigate those risks prior to job execution? And perhaps not a surprise that I think we actually are unanimous. I think everybody watching on the SPE Energy stream and on LinkedIn answered yes. Of course, there would be some value there. But let me ask you, you just went through all of these insights that could be provided from this tool. Why wouldn't a company want access to those insights and clarity in terms of the risks and some of the variables that could potentially dictate success or lack of success for a job? Why would anybody who just listened to you for the last couple of minutes say, yeah, I don't know that I have any value in what you just described?
No, that's a good point. Everybody will want to have access to that information. The problem is the information was not available to them. So what we've done is, over the last decade, we started with our journey of establishing our digital ecosystem. And by doing so, we have been able to enable now with cloud computing, speeding the process. All this information I just described, our engineers will have access to within seconds. And we integrated that into our current process so that it's not significant. It doesn't take any additional steps or any additional processes for them to be able to access the information and provide it to our clients. So it's really not a question of whether they can access the data or not. It's rather we did not have the capability to provide that information based on the tools we had. But now we do.
Got it. All right. So you referenced the database. You referenced all of the information coming in globally. I'm curious, how big is that database? What are we talking about here? How much data is actually being fed into this machine learning model to output the benefits that you just described?
Good question, Joe. So we execute roughly over several hundred thousands of jobs per year. So several thousands of jobs per month. So you're talking about each year we execute anywhere between 25 to 30,000 jobs. All of that information historically is there, and that continues to grow over time. But allow me to show you a summary of the process so that it's also good for the audience. So everything starts with that BIDA database. So if I allow me to go through this process for the audience benefits, everything is in that BIDA database, which is the digital ecosystem. When I design a job, it goes into that BIDA database, and every job that we have executed is in there as well. Then the system identifies the nearest neighbors, which are the jobs with similar attributes than the one I'm defining or designing for. Then the machine learning model scores my job and also scores all of the nearest neighbors, and it shows me a histogram of job scores. It tells me how good I am in relation to all the other successful jobs that have been executed. If I need to improve, then I have to go back to our digital twin model, which in our case is ISAM, in order to improve the practices, improve the standoff, etc. And then I go through the process all over again, up to the point that the score is optimal for improved execution. There's also another part, which is also added values. What are the added values of these tools? So if you go to the next slide, in regards to operators, we expedite the design process for operators. We accelerate engineers' development that are going to be facing or providing this information to operators. Ultimately, we reduce risk, maximize production. We reduce the probability of having any remedial costs. And as a result, we do the job once, we do it right, and we do it right the first time. But for operators, they also have a visual of the entire operation. Just to give an example, in this screen, you see operator A, operator B. The letters or the bars represent each location. So each operator will have access to different countries. Imagine you operating 4 different countries, country A, B, C, and D for operator A. You have an idea of which best practices each location is following. That gives the operator an advantage and a really good tool in order to assess how each location is performing with respect to the other. Where one is failing, what do they need to improve in order to maximize the probability of achieving operational success and reduce risk. Do the job once, do it right the first time.
Great. So one thing on the prior slide that you brought up there in that workflow, again, you already talked about the size of the database and the growing size of the database. What about the number of best practices? How many, what's the order of magnitude, if you will, of the number of best practices that are actually being considered in this model?
Right now, we consider 23 best practices. These best practices are also developed or taken from the API RP65 scorecard. In addition to that, we complemented that with some additional factors and practices that we believe are important to achieving a successful cement job. That's not to say that number will not grow in the future. Of course, we continue to evaluate and to evolve as we keep getting new challenges into the model, into the system.
Got it. Well, thanks for that. Honestly, I'll be honest here, Walmy. I hear a lot from cement engineers who always claim that, you only cement at night, or, they're only called out when it's raining. I don't know if that factors into the best practices or not, but is there any truth to that? Have you seen that yet? Is that a potential best practice that could be incorporated, time of day or the weather when you're going to go ahead and cement?
Good point, Joe. Ultimately, we collaborate with our clients to maximize the value of their assets. So we collaborate and engineer solutions for them at any given point in time. So we don't have no time limitations. Our goal is to collaborate and engineer solutions to maximize the value of our operators, regardless of the time.
Well, enough of my silly questions. That's a good time, again, to remind our audience that you have the chance to ask your serious questions that could actually impact your bottom line here. So take advantage of this. We have a couple minutes left in the show. So go ahead and get your comments, get your questions in there so that Walmy has a chance to address them before we wrap things up today. But for now, I still have a couple more questions, maybe a little more serious. And that is, the barrier advisor model. So how do operators actually benefit? Again, you can connect the dots and say, well, clearly you're improving the odds, but what are they seeing? What are those aha moments that point to the fact that, yes, if we didn't have this barrier advisor model, there's a good chance that we would have went down a path that led to a lack of success. Can you share any stories there or anecdotes about how exactly operators see the benefits of this model and of the insights that are being provided?
Yeah, thank you for the question. So the key benefit is being able to, during the planning phase, being able to assess the risk level that they're going to go into. So during the planning phase, we know how risky the job is going to be, what is the probability of achieving success during the planning phase. So when execution comes, everything goes as planned. That's one of the key benefits. In addition to that, they have access to which are the critical best practices that matter to their job to meet their specific objective. In the past, we know there's a list of multiple best practices, but we really didn't have access to which best practices matter to meet the specific objective. And those are the key values to our operators.
Got it. And I guess another question, I joked about cement engineers and their aphorisms about only cementing at night or only cementing in the weather. But what about the actual, personal development of cement engineering and cement engineers? How does a tool like this that can help make decisions, that can help guide decisions, how does it impact the growth and development of specific people who are dedicated to the science of cementing?
Great point. So as I mentioned earlier in our discussion, one of our critical focus is people. We continue to invest in the development of our people. That's not going to change. And over time, it's the experiences that each of our engineers adopts or obtains in any specific location, having those collaboration interactions with our clients, designing and tailoring different designs to be able to meet a specific client requirements is very important and is invaluable. So those many years of experiences, they're still very valuable to us. What we're adding here in terms of development to our people is that access to that global database, right? Right now, you're focused on your local area as an engineer as to which practices work in the local area, but we're readily available or making that access to that information to those best practices that work in other regions, in other areas, rather quick for them. To give you an example, I'm an engineer in Argentina working in an unconventional well. I have access to the local best practices, but I have no idea easily or rather quick what people in the Middle East or in Australia are actually doing. With Better Advisor and the system and the process that we have in place, we have access or we provide that to our engineers rather quick. And that accelerates and expedites the design process. That accelerates the development that they can adapt in order to be able to tailor those solutions to meet their client requirements.
Got it. All right. Well, let's continue down this path of people. So again, you mentioned from the outset, you just mentioned it a minute ago, the importance of people. What about some of those people who might be identified as skeptics? So again, we're in an industry, a lot of engineers, put on their skeptics hat. How about people who try to poke holes in this process? So, what kind of skepticism do you hear? And then in turn, how do you respond to that skepticism and say, no, this is the real deal here, and this is the value that you should expect from a tool like this?
It just comes down to enabling the tool to answer the specific questions and to address the specific challenges. So we have a tool that assesses risk during the planning phase, and it proves that it achieves success. So just letting the tool show those case studies and those stories to our clients is what proves those specific skeptics, as you mentioned, right? So just having the tool show the process and how we reduce risk and maximize the probability of success. And that's how we show those case studies and those success stories to our clients to be able to answer that specific question and comment.
Got it. So as we kind of approach the end of the broadcast here, we covered a lot. You covered the process, you covered the value, you covered the history of how you would typically approach cementing operations to ensure success. Anything you want to emphasize here as we kind of wind down our time today with our audience? Any key points for our audience to remember, or key questions for them to ask as they evaluate whether they need or to what extent they need and can gain value from a tool like this? Wami, I'll open it up to you for some closing words here for our audience.
Now, thank you for the opportunity. It's important for us to focus on the facts. So some of the facts is that as a Halliburton, we arguably execute the largest numbers of jobs per year. As a result, we have a massive global database, and we've been doing cementing jobs for over 100 years. So we have a significant large number of jobs that we have executed. We have a significant large number of best practices that we have implemented in multiple jobs, all different types of jobs. And we have this tool now that connects all of that knowledge, all of that information, and puts it at service to our operators to be able to reduce risk and maximize the probability of achieving operational success. Again, it's how do we enable data? How do we enable machine learning models to allow you to make well-informed decisions, reducing risk, increasing success, do the job once, do it right the first time.
Great. Well, if for what it's worth, you've done a good job of explaining to this skeptical engineer that there is indeed value in this process. And for those people who are out there watching today who also have some additional questions for you or want to relay some of their skepticism to determine if this is the best fit for them, what's the best way for them to go ahead and get a hold of you, Wami?
They can either contact me, reach out either through LinkedIn at any given time. We're here to serve you. We're here to help. We're here to collaborate with you in order to address your challenges. So any specific challenges that you may have, chances are we have executed jobs in those specific basins or to address those specific challenges, and we'll be able to collaborate, continue to engineer solutions to reduce risk and maximize the value of your assets.
Great. All right. Well, the audience there, you heard Wami. He's there as a resource. Reach out, take advantage of it. Thank you to everybody who tuned in to join us on this conversation today. Thank you, of course, to you, Wami, for shedding some light on the power of leveraging machine learning when it comes to improving cement operations. And of course, a very special thank you to Halliburton. For those of you watching who would like to watch a replay of this show, you can go ahead and do so on the SPE Energy Stream, the industry's digital pulse. Go ahead and visit streaming.spe.org. I'm your host, Joe Sinnott. Join us again next time right here on SPE Tech Talk.
The energy industry is evolving rapidly. To stay informed, you need relevant content available when and where it's convenient for you. Introducing the SPE Energy Stream, the energy sector's platform for quality content from around the world. Energy Stream gives you access to technical solutions, innovations, trending topics, thought leadership, market outlooks, and education. From original programs to exclusive SPE event presentations, this easy-to-navigate platform features insightful content delivered live and on demand. Explore insights from industry thought leaders, then save the videos that interest you so you can watch them at your convenience. Stay ahead of the curve. Start watching SPE Energy Stream today.